Guys, in this video we'll be discussing a challenge called Write 4. So this is our fourth challenge in this whole series. This video I'm just going to talk about Write 4, and in the upcoming videos I'll be discussing all of the other challenges. So without further ado, let's get started. So in this challenge the description says our first foray into proper gadget use. A call to system is present, but we'll need to write a string into memory. Okay, we don't know how to write a string into memory, right? In this video I'll be teaching you how to write a string into memory, in particularly in a place where there's nothing. Okay, click below to download the binary. Okay, let me see. I don't have it. So wget, drag it here, yes, unzip that. Okay, we have the flag.txt and the binary. It is already in executable format, so let's just execute that. Let's give some 1 2 3 input. Okay, okay, we'll start writing our exploit. Open up Sublime. From pawn import everything. Okay, let's open up GDB as usual. Let me see how is main, because it's a not stripped binary. There's a pawn me, and this is not useful. This is not useful in this case because there is a vulnerable function pawn me. So pawn me, and then we have the vulnerable function fgets. This is going to take arbitrary input, so we can take control of the return pointer. But this time, where do we jump to? Let's see that if there's some place we can jump to. Okay, we can jump to useful functions and useful gadget. Let me see what those things are. Let me see what this is. Okay, useful function is basically calling system with an argument. This thing, I don't know what that is. Let me just see what that is. I want it as a string. So, okay, this bin/ls, which is going to list all the file content, all the files and the folders in the server. In this case, our terminal. So we'll see what is there in the useful gadgets. Okay, yeah, this is what we want. This is the only way, or this is the way we write a string to the memory. If you have learned your basics, right, that is, if you know basics of assembly, you know what that is. So I'll explain it anyway. This basically means that the value that is in R15, that is a register, is going to be pointed by R14. Basically, R14 is an address that is going to point the string that is, or the value that is in R15. So that is what this statement means. It is just going to move the value of this to the address that points to this string. So R14 is an address that points to R15. Okay, R14 is a pointer. Okay, so that's nice. So let's craft our exploit. We already know that it is the offset is 40, because the structure is same for all of the challenges up till now. So buffer is 40, and we have to what do we do? Where do we jump to? First, we'll see what are the ROP gadgets that are in this binary. There are a lot of ROP gadgets. Let's see. What do we want? We want to pop R15, right? Sorry. -i is not needed. Okay, we need to pop R15. And R14 is also a register that we need to pop. So I guess this address is important for us. So yep, So let me keep this as useful add address. Let this be our buffer. Okay, in this case the address is going to be the pop arguments or pop registers, whatever you want to call it. I'm just going to convert it to p64 because this is a little Indian and a 64-bit executable. Then after popping we have to set their values, right? First we are popping R14 and then we are popping R15. Okay, so R14 and R15. R14 should be it should be some random address, and R15 should be pointing, it should basically be a string. So let me give bin/sh, but this is not going to work because the number of bytes in this string is 1 2 3 4 5 6 7, but we need 8 strings to completely fill up or exactly fill in the stack. So we create one more null byte which does not affect our payload in any way. So what address do we give here? We can basically give any address that is not used in this binary, and we can also give any address. And if you give such an address, we have to make sure that while running the binary, that address is not going to interfere in any action of the binary, or that address is safe from the binary being run. Basically we have to find an isolated address. So I'm going to fire up the free version of IDA, and yep, IDA. We can basically go here and find something at the last, maybe say, we can say this address. Let's pick this address. You can pick any address. I'm just picking this address because there's a lot of zeros and I love zeros. So that is going to be our address, p64. Okay, so it's going to be OX because it's in hex. And once we set all of those values, we'll just update our buffer. That is, we have to pop these things, pop arguments. Then once we pop it, we have to give the value of first R14, then we have to give R15, then we have to update what is useful here. Okay, once we pop these things, we found there was a useful gadget, right? So we have to make sure we use that gadget and make sure that R14 is an address that is going to point to R15 or bin/sh. So to do that, I'm going to use where was that? It's this one, I guess. I'm going to use this move address. It's going to be moving, right? So I'll just name it move. You can name it anything. These are just variables. So yes, then what can we do? Once we move, we have to update our payload. So move. After moving, we know that system is going to take exactly one call, that is going to be from RDI. So we have to fill up RDI with an address that is going to point to bin/sh, and that is going to be our R14 because that is the address or a pointer that is going to point to this value. So we have to pop RDI, and into RDI we will be setting that value. RDI pop RDI. Yeah, pop RDI. This is not so tough, so I'm just going to write like that, but anyway we'll update our address pop RDI P64, boom. So pop RDI. Once when you pop RDI, we have to give in the value of R14, and then we have to call system, I guess. Yeah, call system, so that system is going to take in the value of RDI, that is basically R14, and then it's going to give us a shell. Okay, so print the system. The system is right here. Buffer plus equals to maybe sys, and sys is going to be P64. Hope this works. Now we start a tube process. It's going to run WRITE write 4, then T dot send line buff T dot interactive. Save it. Hope this works. ape.py. What happened? Oh, that's amazing. We got a shell. So I forgot to tell what is a shell. Basically, a shell is like the attacker is going to get an environment which can basically control everything inside the server. So in this case, the terminal is the server, and we as attacker can now access all of these files and even modify them. For example, we can cat what is inside the flag.txt. That was our main aim of this video. We can even change them. We can remove the flag.txt even. And now when you do this, I'm sorry, ls, see, there is no flag.txt, so we can have all the access. For now, I'm going to exit the shell and end this video. So happy hacking, guys. Please do like this video.